Hi, everyone, and welcome to the Microsoft Fabric UK user group. I'm your host, Leon Gordon, and as always, we are back for an amazing session coming together with Power BI enthusiasts and fabricators, I should say, to learn everything about Microsoft Fabric. So, as always, please do let me know where in the world you're joining us from. As those of you that are keen-eyed will notice, we don't have Pragati, my co-host, with us this evening, unfortunately, but nevertheless, we're going to have a fantastic session. And today we have an action-packed session coming to you. For this session, we'll be looking at real-time intelligence with Microsoft Fabric, and we'll be joined by MVP alumni, Torres. So with that in mind, let me bring Denez onto screen with us. Hi, Denez. Thank you very much for joining us today.
Hello, good evening.
Excellent. We're very, very excited for your session today. So let's go ahead and jump straight in and get started with real-time intelligence.
Thank you very much. Welcome everyone and thank you for attending this session. Today we'll talk about real-time intelligence in Microsoft Fabric. We'll understand better what it is, how does it work, and what's the benefit of using real-time intelligence with Fabric in comparison with other environments. So, this is me. I'm a former data platform MVP with many certifications and I live in Malta. I'm the leader of the Malta Data Platform User Group. On the right side of the screen, you can see my contacts. It will be a pleasure to stay in touch after the session and stay connected in social media, LinkedIn, YouTube, and so on. And if you have any additional questions, you would like to talk more about real-time intelligence or other subjects, feel free to get in touch. So, the agenda today, we'll talk about real-time analysis. First, I'll talk about what we had before Fabric. Then we'll talk about features in Fabric. We'll review some concepts about One Lake, which affect the features that we'll be talking about. Then we'll talk about event stream. And after that, we'll talk about some advanced subjects. Uh, and I'll make some demos in the middle of this process. I'll show it working. I'll show real-time intelligence actually working in this scenario. So let's move to real-time analysis, what we had before Fab. One common architecture used for real-time ingestion is the lambda architecture. The point of real-time ingestion is that the data arrives so fast, so fast, that a regular database, like a relational database, is not capable to support it. So we need to have an ingestion process to support it. In this box where it's mentioning as data sources, user this point is not actually the source. This is a feature, one tool capable to receive the huge amount of ingestion of a real-time intelligence. Before Fabric, this tool was Event Hub. Azure has Event Hub inside Azure. So we can use Event Hub as the entry point for a real-time intelligence architecture. Another very common tool used for this is Kafka. But Kafka is not only for the initial ingestion. Kafka does more than the initial ingestion. I'll mention that in a moment. Then mind that the data that comes from this tool, the responsible for support the amount of data that we are receiving, the data that comes from this tool goes in two directions. Why? Because for sure, we have two purposes for this data. One of the purposes that we may have for this data is that we want to see how our environment is now. If it's about orders, for example, I want to see how many orders are happening now, at this moment. We want to see the information in real time. This is common to happen. Sometimes because I actually want to see the information, sometimes because there is the need to have a reaction to the information. For example, if the information which I'm receiving is about equipment, for example, machines in an industry. Machines can send telemetry about how the machines are working, how the pieces of the machine are working, for example. Then we can analyze this telemetry, and if something is not going well, we can have an immediate reaction to this fact. So we need to see what's happening now and sometimes react to what's happening now. This is one point of what we need. But we also need to archive the data that we are receiving. By archiving the data we are receiving, we can apply many kinds of analysis that we could call as offline analysis, no real-time analysis. We could get this data later and analyze it in Power BI using machine learning tools and so on. So the lambda architecture, which is a very common architecture for real-time ingestion, recommends that we have a speed layer and a batch layer. The batch layer is the one which actually stores the data. It stores the data, and this stored data is left for offline analysis. And we can make offline analysis on this stored data. The speed layer makes online processing on the data which is arriving. And because this online processing on the data is arriving, it has some different concepts than what is usual for us. For example, the concept of a real-time window. The concept of a real-time window may seem simple, but not so much. Uh, the point is, let's say that we are summarizing values. We are making a sum of the values that which are arriving. I may have values arriving every second or multiple values arriving every second. So what window I use to summarize? 1 minute, 2 minutes, 5 minutes. So we have a window of time in which I will summarize the data we are receiving. So we summarize this data according to this window, and then we have the opportunity to display this data. We can use some kind of real-time dashboard, for example, to display the data. The data from the speed layer usually is not kept. We don't store this data. This is used to trigger reactions, trigger some reaction about what is happening now, and to display what's happening now in different summarized ways as needed. But we don't need to keep this data because the batch layer is the responsible for keeping the data. The speed layer in the past, the speed layer was implemented by Stream Analytics. In Azure, we used together Event Hub and Stream Analytics to implement a solution like that. Event Hub was the responsible for receiving the data, while Stream Analytics was responsible for summarizing the data. In other technologies, for example, we still have Kafka. Yes, Kafka does both the work of both tools. Kafka replaces Event Hub and Stream Analytics, does the work of both tools together. Okay, this is an idea of an architecture. We could say that this is an academic idea of the architecture. Depending on the technology we are using, depending on the scenarios, we make some different features in this architecture. We implement these in slightly different ways, but usually not much. This architecture is still the basis for the implementation. So I was talking about what we had before. Event Hub is the responsible for receiving a high volume of data. It's the responsible to ensure that nothing is lost. And the string analytics is the responsible for summarizing the data and make some transformations over the data. For example, this is an example of a transformation in string analytics. String analytics is getting the data from Event Hub and making a transformation using a kind of select statement. In string analytics, the statement is special. It has its own syntax. And there is a control of window. Remind I mentioned about ingestion window. There is a window control here. Uh, is part of the different syntax of the query that the string analytics use. We also have IoT Hub. IoT Hub is used to ingest information from devices, from Internet of Things devices. The difference between IoT Hub and Event Hub is basically that IoT Hub manages the device. IoT Hub has features to manage the IoT devices, while Event Hub only manages the incoming data. All the features that we had in Power BI to handle real time. What we had in Power BI to handle real time? We had the streaming data flows and we had the streaming data sets. These are two features we had in Power BI to handle real time. Both features are considered deprecated. Streaming data flows and streaming data sets are considered deprecated. Streaming data sets still exist in the platform, but it will be removed. There is a date for removal of the streaming data sets. Streaming data flows, I believe you can't create them anymore in the platform. Then, now let's talk about Fabric. Fabric provides us a really actually complete environment for real-time ingestion. I will illustrate how we can do all these steps inside Fabric. So, we have a tool called Event Stream. Event Stream makes the work of an event hub. This is the easiest way to explain an event stream. It makes the work of event hub. Only event hub? No. It can replace string analytics as well. So string analytics and event hub, which were two different tools inside Azure, they can be replaced by an event stream. Can it make the work of Kafka? Well, it can receive data and replace Kafka in an ingestion. It can. Event house. Event house is the place where we will store the data. Why do we need a special place to store the data? Can't I store the data in a regular lake house? Can't I store the data in a regular data warehouse? No, because we are talking about real-time analytics. We are talking about data which will be arriving in a very high flow. The flow of incoming data will be very high. And I already saw some people trying to ingest it into Lakehouse and failing because the Lakehouse was not capable to support the amount of data arriving. The point is, the event house is built exactly to support this amount of data. The event house is built for that. That's why the event house is better for real-time intelligence. It's the best choice for real-time intelligence than the other possible storage. But this is not only the only reason for that. There are more reasons that make the event house ideal for real-time ingestion. This is only the beginning. By the way, maybe some of you may not be recognizing the event house name. The point is, this is Kusto, a Kusto database. In the beginning of Fabric, this was called a Kusto database, and Microsoft decided to change the name. If is Event House a Kusto database? Not exactly. Event House is an aggregation of Kusto database. An Event House allows you to aggregate multiple Kusto database inside the same management structure. You can manage properties of multiple Kusto database in a single structure. This is the event house. Then, to display the result, we have real-time dashboards. We need a special reporter to display the results because the results are arriving in real time. It's like something that requires a continuous refresh of data. It requires to be continuously being refreshed and displayed, refreshed and displayed. So we need real-time dashboards. But why is Microsoft creating something different? Doesn't Power BI has the dashboards to do that? Doesn't the dashboards, actual dashboards, not reports? There is a mix of names between dashboards and reports in Power BI, which is quite interesting. But I'm talking about actual Power BI dashboards. Don't they offer uh, automatic refresh for real time? There is a limitation. The Power BI dashboards only offer uh, an automatic refresh for real-time data if this data is coming from a streaming data set. But the streaming data sets are deprecated. So we can't have the automatic refresh of real-time of Power BI dashboards anymore. And configuring reports for an automatic refresh sometimes it's more complex than we would like it to be. So Microsoft came up with a completely new object called real-time dashboards. And we have Data Activator. What's Data Activator? What's the purpose of Data Activator? Just to be sure that no one is mixing names, that we don't get lost in relation to names. When Fabric was born, when Fabric was in its early stage, Data Activator was called Reflex. Then Microsoft decided to change the name to Data Activator. What is this? Is the capability to trigger an action from the data which is arriving. So, according to the data arriving, we can uh, check some criteria on the arriving data and take actions on the arriving data. So let's talk more about the event stream and let's see a comparison in relation to other tools. This is not only a comparison in relation to other tools. Inside Fabric, we use an event stream. But Fabric is totally based on Azure. The features which we use on an event stream now are underneath them. They are Azure features. So the event stream receives the data and puts the data in an event house. This in Fabric. But what's happening behind the scenes and that we don't see is that Fabric is using Azure to implementing these features. Fabric is actually going to Azure and implementing these features using Event Hub and String Analytics. It uses Event Hub and String Analytics for Event Stream. And the Event House, which is a Kusto database, is the Azure Data Explorer. So these features in Fabric, they are powered by the features on Azure, by the solid structure that the features on Azure have. However, The features in Fabric are built to be way easier to implement. Implementing this in Azure has many more steps than I will display today, than I will demonstrate today. It requires many more analysis, many more configurations, and so on. While in Fabric, we can do this during a live session like I will do now. Before moving ahead with some concepts, let's talk about one lake, and then I will explain some additional details. It's important that we are aligned in relation to one lake concepts. One lake is the storage used for Fabric. Every computing feature use one lake as a storage. So if we have a lake house, the data is stored in one lake. If we have a warehouse, the data is stored in one lake. Custo is stored the data in one lake. So we have a common storage for all the data. Is this true? Not exactly. This is a purpose. This is a final purpose, what we want to reach, but not a perfect truth. What's the truth, especially related to Event House, especially related to our Custo database that we will use during a real-time ingestion? The Event House supports the ingestion rate needed for real-time, but Custo database in an Event House has its own internal format. It's not saving directly to one lake. It would not support the ingestion rate. To support the ingestion rate, the Custo database has its own format, our own internal format. And then Custo synchronize with the, sorry for the mistyping, it was intended to be one lake. Sorry for the mistyping there. Custo synchronizes one lake. So Custo receives the data, it stores the data in a format managed by Custo and synchronized to one lake to ensure that one lake is still a common storage for all the processing features that we use in Fabric. So it's not that everything is stored in one lake, but everything is synchronized to one lake to be accessible to other tools. The sharing, this synchronization, this sharing is activated by a database configuration. So we need to make a configuration at level of the database. We can make this configuration on the database level, or we can make this configuration on the table level. But there is a reason why I'm highlighting this before the demonstration, because it's very important that once we create the event house, we enable this configuration. Because every information in the event house is only synchronized to the one lake after this configuration is active. Any information which arrived to the event house before this configuration was enabled will never be synchronized to the one lake. So if you spend a month receiving data, if you spend a month receiving data and this configuration is disabled, when you enable this configuration, you lost a month of data. Not that you lost, you kept that data isolated in Custo and not shared with the rest of the Fabric environment. It will do not be shared in the one lake environment. Only after activating this configuration, uh, Custo will be synchronizing with the one lake environment and we actually saving the data in one lake. This synchronization is what makes possible for other data tools, such as Lakehouse, for example, to make shortcuts to Custo. A Lakehouse can make a shortcut to a Custo table and make a query over a Custo table. Can, yes, a lakehouse can do that. But this is only possible if this configuration is enabled, and it will only have access to the data which arrived after this configuration was enabled. So we need to take care with this configuration, be very careful with this configuration. But the latency is a problem. Uh, it's a fact that Fabric evolves every day. So soon we will see different scenarios for this. But I faced scenarios where I see a Custo database with a latency of up to 2 hours to synchronize to the lake. This means that the one lake stays 2 hours behind the content which is arriving in Custo database. This happens especially if the flow of data arriving to the Custo database is very high. Higher is the flow of data, bigger will be the latency to synchronize to the one lake. So, the internal format that Custo uses gives Custo the capability to actually receive a huge amount of data very fast. And this is what makes Custo the recommended solution when dealing with real time. That's why we should choose Custo and not a lakehouse or a data warehouse. This is the configuration I was talking about. We enable the sharing with the one lake, and then our one lake folder becomes available. In this example, this database is enabled with this sharing with one lake. Once this is enabled, it will Custo will synchronize the data with the one lake according to the data arrives. Once we activate the synchronization, Custo will synchronize with the one lake. Let's see some demonstrations. I will first start creating the objects. I already have some of the objects here. The objects I have here, let me be sure I can make a zoom. The object I have here is a lake house, and I have a query set. A query set is what the name says, a set of queries for Custo, for the Custo database. I have some examples inside this query set, which I will show later. So let's create a new item, and I'll create an event house. Event house. Let's go real house. Create. So I'm creating my event house. Okay, here in the event house, I have in fact the management of a set of Custo database. Not only one Custo database, but a set of database. And I can create more database to be managed by the same event house. Multiple database can be managed by the same event house. So here I have the first database, real house, and the configuration was talking about. The availability of the data in one lake, it's off by default. This means that the data which arrives in Custo will not automatically be synchronized to one lake. And only the data which arrives after I enable this option will be synchronized to the one lake. Turn on. So it's turning on the synchronization. So everything which arrives in Custo after this moment will be synchronized to one lake. There is a query set linked to the event house. We can use this query set to make queries over the event house, but as I illustrated before, before the event house, I had a query set saved in my workspace, so we can have independent query sets. There is a query set tied to event house to help you to make some direct queries directly to it, or you can use query set independent from the event house. There are some policies that we can define, especially retention policy and caching policy. Caching policy defines the storage of the data, defines if the data will be stored in a premium storage, which means in an SSD environment or in a standard storage. The symbols are used because this is considered as hot data and cold data. Of course, the hot data will be faster. The cold data will be slower because it will be stored in a slower storage than the SSDs. The hot data is stored. By default, the caching policy basically store. We could say it stores everything inside inside the premium. It's set as unlimited. Unlimited. It will store everything in premium. If we want to set a limit, we can. But why? In my practical experience, the price difference to create a limit on what you leave in premium and isolate the rest in the standard, the price difference doesn't worth it. Doesn't worth using the caching policy. So we end up not using. So we have this possibility with the event house, but we end up not using. And about the retention policy. The retention policy is very cool, especially if we think the Custo database the speed layer, as the speed layer of the Lambda architecture. I told you before, we don't keep the data on the speed layer, we drop it. We look to it, analyze it, and we drop it. So we can create an automatic drop of this data after a specific amount of times. That's what the retention policy does. It specifies how long the data will be stored in Custo. The retention policy is extremely useful, but according to my experience, is not that useful at the database level. Usually, you would like to create specific scenarios with the retention policy on a table by table level, not on a database level, but you can. You see that on the management level, you can set a retention policy on the database level, but you don't need, and most of the times you wouldn't like to set these on the database level. Okay, so I created the event house. The event house is there. Now I'll create the event string. The event string is the object responsible for receiving the data. Let's call our event string as incoming data. This is the name of my event string. Create. It's preparing my event string. Okay. Now I need to design the event string. Design the event string. What's that? What this means? What does it mean to design an event string? Well, I'm receiving data from somewhere. I need to define a source. Where will I receive the data from? I need to define a source for my data. I can use external sources, And there is a specific set of sources supported by an event stream. Azure Event Hub and Azure IoT Hub. This means that if I want to combine the Fabric solution with an already existing Azure solution, I can. If the solution already exists in Azure with an event hub, the applications are already sending data to that event hub, and I want to put Fabric in the middle of the process, I can connect to an existing event hub, or I can connect to an existing IoT hub on Azure. That's perfectly possible. Two other options, these are almost a kind of internal fabric option. What I say internal fabric option is like meta options because we use these options to manage the fabric environment. We can trigger events and capture data in relation to the Fabric environment. Like, for example, knowing who is changing what inside Fabric, for example. So these are almost like meta options, and they are very interesting, very important. And I built some videos about them, about what we can do with these two options. Okay, so we saw the sources can be Event Hub, can be IoT Hub, but I also have sample data as possible source and custom endpoint as possible source. Okay, these are possible sources. Let me choose the custom endpoint. By choosing a custom endpoint, this means that my event stream will be passive. My event stream will be receiving the data, will be waiting the data to arrive. Let's go, let's go test because I will drop this custom endpoint in a moment. But just to illustrate that by choosing a custom endpoint, my event stream becomes passive. It's waiting to receive data. And then I need to set a destination. The destination could be a lake house, an event house, activator, data activator, or a custom endpoint. Let's talk more about this. Let's get back to our slides, talk a bit more about this before we continue the demonstration. So, about the event stream. The event stream receives the data, transforms the data, and delivers the data to a target. Possible sources, Event Hub. We can connect the event stream to an event hub, IoT hub. Yes, we can connect the event stream to an IoT hub. Custom app. In this case, our event stream will be waiting a custom app to send data to the event stream. I'll talk more about this in a moment. And sample data. Sample data is used for experiment, and I will use now in the demonstration. We can get a sample data set to use to test the real-time feature. That's great. So we see the sources possible, and we have multiple methods of use of the event stream. What do I mean? I mean, depending on the way that we combine the source and the target, we are using the event stream in different ways. If we put a custom endpoint, the event stream is replacing Event Hub. We don't need Event Hub. The event stream is a complete solution. It completely replaces Event Hub. Underlying the event stream is already using Event Hub when we do something like this. It can consume from Event Hub. In this case, it will use an existing Event Hub on Azure. It will consume from an existing Event Hub and transform the data. In this case, the event stream is replacing the stream analytics. Replaces the stream analytics. It can act as a Kafka endpoint. When you choose custom endpoint, the custom endpoint can use a Kafka API. So if you have an existing Kafka application and you want to migrate from Kafka to Fabric, the event stream can act as a Kafka endpoint, and we can just redirect the application to start sending data to the event stream in Fabric, and Fabric will receive the data. That's great. And it also has the protocol AMQP, which is a standard pattern for this kind of streaming, this kind of receiving streaming. Is a standard pattern that many third-party applications use. Here you see how the event stream can have an event hub endpoint. This means if you have an application prepared to send data to event hub, you only need to point to the event stream because it has an event stream endpoint. The same for Kafka. If you have an application prepared to send data to Kafka, you can point to the event stream. AMQP, the same. And the three at the same time. Yes, you can get an Event Hub application, a Kafka application, and a third-party application, integrate all three in the same event stream, and the event stream will receive the data and make the same processing for all three. Yes, that's possible. It's curious how the event stream sometimes can act in an active way or passive way. What do I mean? If you define an event hub or an IoT hub as a source, the incoming of the event stream will act in an active way. It will go to the hub to get the data. But if you define a custom endpoint as the source, it will act as a passive way. It will wait an application to send data to it. So the event stream can be active and can be passive. And this is on the input, but also in the output. Uh, for example, you can define as an output a custom endpoint. If you define a custom endpoint as an output, this means that the event stream will be waiting other applications to collect data from it. It's like if the event stream is replacing Event Hub, but other application needs to come here and collect the data. Or connect in an active way, can put the data, deliver the data directly to a target, like Kusto, for example, like an event house or a lake house. It can send the data directly to a target. Possible targets, Kusto database, KQL database, lake house, data activator to trigger an action, from the event stream, or custom app to open an endpoint for connection, which is compatible with applications sending or retrieving data from Event Hub, from Kafka, or some third-party environment, the destination. Let's complete our demonstration. So, let me remove this source. Now I use sample data as source. The source needs a name. I need to create a name, taxi rights. And see, these are the data, the sets of data that we have as sample. Yellow taxi, stock market, or bicycles. I choose yellow taxi. These are data for taxi rides in New York. Add. Oops. Click it twice. There it is. So I have the source taxi rides, bring in the data, incoming data, and I need to decide what to do with this incoming data. One possibility is to send this data directly to a target. For example, I can send this data directly to an event house. When I send the data to an event house, I have two possible options in the method which I'm sending the data. I can use an event processing before ingestion, or I can use direct ingestion. What's the difference? Event processing before ingestion means that the event stream itself will make some transformations on the data before the target receives the data. The event stream will be transforming the data. If I choose direct ingestion, on the other hand, this means that the data goes directly to the target. The target will directly receive the data, in this case, the Kusto database. Then, if any transformation is needed, is responsibility of the Kusto database. It's interesting. It's like if we choose direct ingestion, it's like Event Hub sending data to a Kusto database. If we choose processing, it's like Event Hub sending data to a String Analytics, which send data to a Kusto database. That's interesting. Let me choose on the first example, choose direct ingestion. So, destination name. I need to set a name to my destination. And it's not a good idea to put a name according to the target because we may send many different tables to the target. It is better to think in a table level way. Let's think about raw rights, raw tax rights. So, what is the event house that we use? Real time UK. Event house, real house, real house. Okay. So, safe. So, I defined my first line of injection, but the point of an event string is exactly that I don't need to stop here. I can make many additional definitions. Um, I use one of the possible transformations which I can make in an event stream, for example, manage fields. Why I'm using manage fields? Because I know that some fields here are arriving as a string and I want them to be numeric. So I'll get another line from the incoming data and drop to manage fields. So first, I send the data in a raw format to Kusto. Kusto will have a raw table with the original data, but I also want to make some transformations. In this case, manage fields. Let me just discard this. Okay, to make a better demonstration, it's better if I first publish the first example. I'll publish the first example. Publish means that the event stream becomes active. By becoming active, it means that the sample data is already sending data, and this data is already arriving to the event string itself. The incoming data is already arriving to the event string. The event house is still processing, is still thinking about this problem, but the configuration for a direct ingestion doesn't finish at this point. The configuration for a direct ingestion needs to be completed after the publishing. So I have data in the incoming data, but here it will tell me the event house is not fully configured. The configuration of the event house still needs to be completed. Let's wait some moments. Okay, there. The configuration of the event house still needs to be completed, but I will not complete now. I will go back to edit and include the manage fields which I was already including before. And now I will link the incoming data with the manage fields and edit the manage fields. What changed? Why I decided that I needed to publish? because once I publish, the sample source becomes active. The event string is actually receiving data, fake data, sample data, but is receiving. So in this way, the manage fields has the option to add the existing fields because the manage field has an example of the existing income. So I add all the fields from that are arriving from the source. And what I need to do is that I'll change the type of some fields. Some fields are string, I'll change to double. The fair amount and the tip amount. I'll change these two fields to double. Save. It's telling me it's an error. Yes, because I haven't put a destination yet. I need to define a destination for this, but not yet. First, I'll make a grouping. I want to summarize this data. So make a grouping. I'll get the data from the managed fields and make a grouping of this data. I'll use the group by. It's curious that there are two redundant actions here, an aggregate and a group by. The group by is the most complete one. I extremely recommend to use the group by. From my point of view, they are redundant. I will define the grouping field. The grouping field here is the PU location ID. What is PU location ID? For this set of data, this means the pickup location, the location the ride started, and the location the ride finished, drop off location. So I will summarize the data according to the pickup location. And this is only an example. Of course, I could summarize way more. I could make many summaries from the pickup location with the drop-off location as well. But I will only use this, a summary by pickup location. And I can make aggregations. I can make, for example, a count of rides on every 5 seconds. Mind that I mentioned about types of window, time windows that we use to aggregate data. We have this option to configure here. I can configure time windows. I will not go deeper on the explanation about what's the difference of all these windows. This would take way more time. Total rows. So I'm adding the total of rows as an aggregation. Add another aggregation. I'll make a sum, and it is showing me exactly the two fields that I converted to double. The fair amount I will call as total fair, add, and I will sum the tip amount. It will call total tips. Add. Add and save. Now I have my data grouped and I can add a destination for this data, which will be the event house as well. I will define my event house. Um, Custo summary, workspace, real time UK, event house, KKL database. Okay, it doesn't allow me actually to create a table yet because I haven't linked this. What would happen if I choose direct ingestion? If I try to link this with the direct ingestion configuration, it doesn't work. The direct ingestion only accepts the data directly from the incoming data, and Custo will be the responsible for the ingestion. This is an event processing. I already processed the data, so the data is processed before arriving Custo, and now I create the table based on the data that I have, that I transformed. Let's call rides summary. Right, summary. save. The data is saved, and I can add another destination as well. I can add the lake house as a destination. I can add a lake house as a destination. Let's put he has a lake summary workspace real time UK lake house, and let's get another line from the group by to the lake house, and I put the lake house as a destination. Create new, and name of the table, write summary in the lake house. Done. This table will be created inside the lake house. That's it. So I have my raw data being ingested inside Kusto, and summarized data being sent to a different table also in Kusto and to a table inside the lakehouse. So I created an entire process of ingestion inside this event stream. But this is not actually similar to the lambda. No, it resembles the lambda. But if I try to be strict with the lambda, for example, the idea would be that the customer would get the real-time action, the speed layer, and the lakehouse would get the batch layer. But the lakehouse may not be good to ingest a huge flow of data, may fail. So sometimes the technology forces us to adapt to the lambda architecture. So publishing the full topology. So uh, mind that the direct ingestion it still requires an additional configuration that I haven't completed yet. I need to click in this configure button to complete the direct ingestion configuration. This completion will define the table inside the event house and will define transformations for this table. Let's say the table will be taxi rides. A direct ingestion creates an object called data connection. This data connection will be the responsible to connect the source of data to the Custo database and to define transformations on this data in the Custo database. In this situation, when we choose direct ingestion method, the transformations are inside the Custo database, not in the event stream. Let's wait a bit. Okay. Um, and here we may note the data type. These two automatically identify some values as data type real, trip distance, rate goals, some date time. You note that when the data was arriving in the event stream, the data was arriving totally as a string. I had to use the manager field to make data transformations, type transformation. The fair amount is already being identified as real. The injection into custom made the data type identification, and I will finish the configuration. It's creating the ingestion, direct ingestion process inside the custom environment. So it takes some moments for the custom ingestion using the direct ingestion method to be actually active and receiving data. Okay, now we just need to look to the results. I need to open the Kusto and the Lakehouse to see that the data is there, is actually there. Um, Let me open my query set, real time UK. Let me refresh. It takes a moment for everything to be in place. Here, both tables are already in Kusto, ride summary and tax rise. One of them, ride summary, is the summarized by the event string, and the other one, the tax rise, is one using direct ingestion in Kusto. And the additional object that was created, it was created for the tax rights table, for the direct ingestion. There was a data stream created because for this tax rights, Kusto is receiving the data directly, as if it were receiving from an event hub, while the right summary doesn't have a data stream. On the real lake, let's make some refreshes here. The table will be here as well in the lake house. There it is, the right summary being delivered to the lake house. And let me refresh my event stream. My event stream is live and delivering the data for Custo and for the lake house. So in this way, we just saw how to build what is like an entire lambda architecture. We just saw how to build an entire lambda architecture in a same environment using Microsoft Fabric. I had no need to keep changing from one tool to another. I use a different Fabric features in relation to the target of the data. The event house, the lake house, everything inside a single environment. If I were doing the same in Azure, it would be way more difficult to build all this. So Fabric is providing us a layer over Azure to make everything way easier and way faster to be built. Let me give some reference links that you can check later. Where it is here. So I have a video of real-time intelligence with a demonstration of real-time intelligence. You can check later. This presentation is being recorded. The recording will be available immediately after the presentation. And I have some short videos about the additional features, which I had no time to talk about. Talk more about real-time dashboards to show the real-time data and data activator to trigger actions from the real-time data. So these are two very interesting references. And thank you very much for attending the session. Here are my contact links. It will be a pleasure to stay in touch. And is there any question anyone would like to ask anything about what we just saw?
Thank you very much there, Dinesh. Absolutely fantastic session there. And I feel like we're only touching the very introduction of the possibilities available for real-time intelligence. The mind boggles, I think that some more advanced sessions looking at CI/CD, for example, within this environment. And then you've mentioned also going to look at query sets as well in a bit more detail. I think that they would be very interesting points that our audience would love to know more about. I think that one of the main questions that I'll pose to you now, because I know that we're nearly at time, is what is one of the biggest obstacles that you see for organizations adopting Fabric for real-time intelligence?
Fabric was born some time ago, and when Fabric was born, it hadn't all these features, and these features are the result of an evolution that came step by step. An organization that accepted the challenge and got into Fabric from the beginning passed by many hard moments where the features were becoming more solid. But what I demonstrated here is almost closing to an endpoint of this moment. These features are already in a solid state where in a single presentation I was capable to build the entire sequence with two different kinds of ingestions to three different targets with absolutely no problem at all. So these features are absolutely solid. Now, I believe I don't see actually a big challenge in the state that the features are at the moment. I only see benefits because uh, if the company is starting some kind of greenfield project, if the company doesn't have any real-time intelligence ingestion, it will be way easier to build this ingestion in Fabric. It will be way faster to be built than in Azure, for example.
Absolutely amazing. All I'm hearing is benefits then for not just for the development team, but also for the organization as well. So I think that what I'd
Definitely.
love to do, Denez, is definitely have you back with us in the future to unpack this in a bit more detail and really start to show some of those benefits.
Sure. We can have additional sessions talking about additional points of the real-time intelligence. This was just the beginning.
Amazing. Thank you very much. And if anybody does have any further questions for Denez, please do feel free to reach out. We've put your contact details directly into the chat as well. And also, as you can all see on screen, Denez is readily available on all of the favorite social networking platforms. Fantastic. Okay, Denez,
Thank
thank
you
you
very much.
once again for that session.
Thank you very much.
Perfect. And I'd like to thank everybody here for joining us as well at the Microsoft Fabric UK user group. You could have been anywhere in the world, but you've been here with us. Stay safe.